Welcome to Mimi's Math Channel. I am going to build a unit circle with you guys today. All right, the first thing I want to do is start off with my 30 degrees, and that's going to be located here right next to my 0 degrees. So I'm going counterclockwise, and you will notice that each quadrant is going to be 90 degrees. So for a total of the entire circle, which is 360 degrees. So if I wanted to try to figure out just the green lines that I have diagonally, what I would do is I would just draw in like a little right triangle just to get me started. And then I would recognize that this is one of my special right triangles, 30, 60, 90. But what I need to know in order to find my sides is that no matter where the radius is in the circle, it's always going to be 1. So the radius means it's coming from the center of the circle and it's touching the circumference of the circle. I'm just only focused on the green ones right now. And that's going to be, not only is that my radius, that's my hypotenuse. If I draw down my lines on my triangle, so let me do that on all sides. So now each of these angles are like 30 degrees, but as I count, they're going to progressively get bigger. You'll see what I mean in a minute. So in the first quadrant, if I'm trying to find the opposite side of 30 degrees, I could use my trig ratio for sine because I already have my hypotenuse, which is 1. So sine of 30 is going to be 1/2. Or if I recall my rules for 30, 60, 90, then I would know that I have x, and then I have x root 3, and then 2 times x. You can try to figure it out that way as well. Well, if you did that, you would know that you already have your hypotenuse, so 2x is 1. And then I want to figure out what x is, I would have to divide both sides by 2. So now I know that x is 1/2, and then I take that 1/2 and I multiply it times root 3 to find my adjacent side. So that's going to be root 3 over 2. And that's all I really need because, of course, if I put 2 times 1/2 here, the 2's will go away, and now I'm left with 1, which we already knew the 1 to begin with. So that's another way that you can do it. And like I said, you can do the trig ratio, which is sine 30 is equal to opposite over hypotenuse. Well, opposite you didn't know, and hypotenuse you did know. So now I would just multiply both sides by 1, and that will leave me with x is equal to 1/2. So you have options. And if I did not know the rules and I wanted to find the adjacent side, then I would use cosine of 30, which is adjacent. Now that time, we're trying to find the bottom part of this triangle if we were looking for quadrant 1. And so we would say adjacent over hypotenuse. And again, we're going to multiply both sides times 1. And if you were to actually, in your calculator, but eventually you're going to have to memorize it, figure out what cosine of 30 is, it's going to be root 3 over 2. So let's go ahead and create that ordered pair. So over here, I have for my, and this was my y value. So that's going up and down. So y value is going to be 1/2, but we just said the x value, which is when I did the cosine one, this is what we said. So root 3 over 2 and 1 over 2. That's how I find my x and my y values. So now what I want to do is I want to recognize that that was quadrant 1. So both of the signs are going to be positive, positive. If I were to take this same triangle and I reflected it over, this side is still going to be 1/2 because that's my y, and they're the same distance going vertically up. So I know for y, I'm still going to have 1/2. The only difference is I have to pay attention to my signs. So my signs over here are going to be negative, positive. Remember, x comes first and then y. And over here, like I said, is positive and positive. So I know that my y is still 1/2. However, my x, even though it's the same value, it's going to be negative root 3 over 2. Now, if I were to flip both of those triangles over the x-axis, I'm still going to have the exact same, I shouldn't say exact, I'm going to have the same values, but the signs are going to differ depending on which quadrant I'm in. So for quadrant 4, my signs are going to be positive, negative. So I'm still going to have root 3 over 2, but this time I'm going to have a negative 1/2. And then if I were to flip that triangle over the y-axis to the left in the third quadrant, my third quadrant, both my signs are negative. So same value for the green, except negative. Negative root 3 over 2 and negative 1/2. So now we're going to go and change the color to pink. The next one is going to be where it's 45 degrees. And same thing, if I were to actually draw down a right triangle, if I did that, it's going to be the same thing, and I can keep going down to the next one. And the next one. Now, I said the radius is always going to be 1, so it doesn't matter which one of the triangles I'm working with. I just need to know where my right triangle is, so I'll know where my hypotenuse is. And then I can do the same thing. I can either use my rule for 45, 45, 90. Let's see if you remember that. So 45, 45, 90. The rule was x, x, and another x, but this time multiplied times root 2. What we know is that our hypotenuse is 1, so we would just take that x root 2, set it equal to 1, and now to find x, we would have to divide both sides by root 2. We cannot have a root in the denominator, so we have to rationalize it. So root 2 in the numerator and root 2 in the denominator multiplied by the initial fraction would give us root 2 over square root of 2 times square root of 2 is square root of 4, square root of 4 is 2. So my x value would be square root of 2 over 2 for both sides, since it's a 45, 45, 90 triangle. So what that means is this time I'm going to have root 2 over 2 and another root 2 over 2. And I'm going to do the same thing with reflecting. So I'm going to reflect over to my second quadrant, which has signs negative and positive, but I still have the same coordinates. So negative root 2 over 2, and then positive root 2 over 2. I take the same triangle and I flip it down to quadrant 4, and I have the same values, except the signs are different. So I have a positive root 2 over 2 and a negative root 2 over 2. And now finally, I'm going to flip it over or reflect it over the y-axis into the third quadrant. And my signs are negative, negative, but the same values. Negative root 2 over 2 and another negative root 2 over 2. So now we're going to go on to the blue. And so what you will notice what I'm doing in terms of how I'm determining which angle. So we started out with 30, and then there's a special right triangle that we used. It was 30, 60, 90. So our next one is going to be 60. 30, 60, and then we also had 45, 45. So that's how we're going to build it. All right, so for the blue one, if I'm trying to find this side, I can use sine of 60, and that's going to give me root 3 over 2, and that represents my y value. And I could also, for my adjacent side, this side here, I can use cosine of 60, and that's going to give me 1/2. So these coordinates are going to be 1 over 2 and root 3 over 2. Notice again, it's positive, positive. I could have also used my rules. I could have used that 30, 60, 90 rule that I showed you before. So that's this one side. Now, if I were to reflect it over my y-axis, I'm still going to have the same values, but my signs will change. I will now have a negative 1 over 2 and a root 3 over 2. That's positive. If I further reflect and go to my fourth quadrant, I am going to have a positive 1 over 2 and a negative root 3 over 2. If I reflect this over into the third quadrant, I'm going to have both negatives. So negative 1 over 2 and negative root 3 over 2. Now those are my coordinates for the green, pink, and the blue. So now let's go to our actual axes. All right, so 0 degrees is what we started with. Then we went up to 90 degrees. So I'm just gonna put that right here. So 90 degrees, well, that's just on our axes. So that's gonna be 0, 1. And then my 0, 0 on my x-axis, my 0 degrees is gonna be 1, 0. And now if I go over to the other side, that's going to be -1, 0. And then finally, if I go down to the bottom, because remember, everything, the radius is going to be 1. So this is going to be 0, -1. All right, let's fill in the rest of the information. Let me label this whole thing 90. I'm just going to label the ones that are on the X and Y axes. So let me move this 0 over. So this is going to be 0 degrees. This is going to be 90. I already did. This is 180 degrees. Down here is going to be 270 degrees. And right below 0 is going to be 360 degrees. That's the full circle. All right, so go ahead and finish putting my degrees on there. Like I told you, we're going to count like by 30 degrees, and then we're going to do 15 degrees, another 15 degrees. So 90 plus 30, that's going to give me 120 degrees. So notice those blues, they're going to go together. And if you look at the actual coordinates, you see that they actually go together. And then if I go to the pink, then 120 plus 15 is now 135 degrees. Then we're going to go on to the next one. 135 plus 15 is 150 degrees. And now we're back counting to 30 degrees. All right, and then 150 plus 30, we already said is 180, so that's already labeled for us. Then we start the process again. So 180 plus 30 is going to give us 210 degrees. And again, the greens stay together because the greens have the same coordinates. And then I go to the pink. 210 plus 15 is going to give me 225 degrees. Now I'm going to add another 15 to that, and that's going to be 240 degrees. Add 30 to that, and I've already accounted for that. That's 270. And now the next blue one, 270 plus 30 is going to give me the 300 degrees. So 300 degrees. The next one, we're going to add 15. So that's 315 degrees. We're going to add another 15. And that is going to be 330 degrees. So I tried to color code it as best as I could. And then once you add the other 30, it's going to give you 360 degrees. So hopefully that kind of helped. Now what we have to do is go in and convert these degrees to radians. And we did that in another video, but I'll just remind you what the formula is. You're going to take whatever your degree is, and you're going to multiply it times pi radians over 180. So that's what your formula is going to be. So whatever your degrees are. All right, so we already know 30 times pi radians divided by 180. That's going to give us pi radians over 6. For 150, that one is going to be 5 pi radians over 6. 210 is going to be 7 pi radians over 6. And again, just use that formula and you'll see where I'm getting this information from. For the 330, that's going to be 11 pi radians over 6. Let's go to 45 now. So if I do 45 times pi radians over 180, that's going to give me pi radians over 4. If I do 135, 3 pi radians over 4. For 225, 5 pi radians over 4. And then for 315, 7 pi radians over 4. So what are you noticing? What you should notice is everything in green was over 6, Everything in pink is over 4. Let's see what's going to happen with the blue. For 60 degrees, that is pi radians over 3. For 120, that's 2 pi radians over 3. For 240, 4 pi radians over 3. And for 300, 5 pi radians over 3. See a pattern? For 90, it's going to be pi radians over 2. And then for 180, it's simply pi radians. For 270, it's going to be 3 pi radians over 2. For 360, it's going to be 2 times pi radians. Because remember, pi radians does not equal 3.14. Pi radians is equivalent to 180 degrees. So make sure you understand that. All right, 180 degrees. So that should make sense when you look at 360, which is 2 times 180. Or if you look at 90 degrees, where it's pi radians over 2. So that's 180 divided by 2. So that's equivalent to 90 degrees. So that should make sense to you. Another thing that you can notice is if you're looking at the first quadrant and you're looking at the coordinates, it's going to count 1 over 2, 2 over 2, 3 over 2. Everything will have a radical on the top. But if you take the square root of 1, it's simply 1. That's the only reason that one did not remain with a radical. Then you want to count in the other order. Back up. 1 over 2, 2 over 2, 3 over 2. However, they all should have radicals in the numerator except for the 1/2, because the square root of 1 will simply be 1. Once you figure that out, everything else has the exact same pattern. You just have to know the signs. So I think this is all that you will need to know. Make sure that you practice, because you will see this often. Make sure your signs are good. And that's it for this video. Please like and subscribe. Have an awesome day.
Subscribe.